Hello and welcome to this video. In this video, we are going to solve some of the circular measure questions from the recent past papers. The first question, the diagram shows the motif formed by the major arc AB of a circle with radius R and the center O, and the minor arc AOB of a circle also with radius R but with center C. The point C lies on the circle with center O. Given that angle ACB is equal to k pi radians, state the value of the fraction k. So the angle ACB, here the angle is k pi. Okay, we need to find the value of k. So it's given the point C lies on the circle with the center O. That means OA is R, then OC is also R. Because this is the radius of the circle with center O. In triangle AOC, all the three sides are equal. OA is equal to AC, which is equal to OC. Okay. All the three sides are equal, so it is an equilateral triangle. So all the three angles are equal in an equilateral triangle. Okay. And which is pi over 3. So this angle is, so here angle ACO is pi over 3. Here OB is R and CB is also R. So triangle OCB is an equilateral triangle. So angle OCB is also pi over 3. So angle at ECB will be 2 times pi over 3. Which is equal to 2 over 3 multiplied by pi, and this is of the form k pi radians. So k is equal to 2 over 3. Okay, compare these two. K is 2 over 3. The next part of the question is state the perimeter of the shaded motif in terms of pi and r. So the perimeter of the shaded motif is nothing but adding this part and this part. That is perimeter equal to major arc AB plus minor arc AB. And we know the arc length formula is r theta, and we know the radius here is r. So the arc length of major arc AB is, the radius is r, and what is the angle theta? So you need to take this angle. This part is equal to 2 pi over 3. Okay. So this angle will be 2 pi minus 2 pi divided by 3. So for the major arc, the angle is 2 pi minus 2 pi over 3. And what is this arc length of minor arc AB? Angle at C here is 2 pi over 3. Okay, that will be the angle for the minor arc AB. So R multiplied by 2 over 3 multiplied by pi. Okay, let's simplify this one. R multiplied by 6 pi minus 2 pi, which will be 4 pi, 4 over 3 pi r plus 2 over 3 pi r, which is equal to 6 over 3 pi r. That means 2 pi r. So the perimeter is 2 pi r. The next part of the question is find the area of the shaded motif, giving your answer in terms of pi, r and square root of 3. To find the area of the shaded region, let me join O and B and find the area of the major sector AOB. Okay, from that we need to delete these two portions, these segments. Okay, let's find the segments area. Now let's consider the segment, this part. Let's join this line, and this is also R, we know that. Okay, so now consider this ACO. Okay, to calculate the area of the segment, the shaded blue color shaded region, you can find that by finding the area of the sector ACO minus the area of the triangle ACO. You will get the shaded region, area of this shaded segment. Okay, so that segment has to be subtracted from the area of the major sector AOB. Okay, so the area of the motif is equal to area of the major sector AOB minus 2 times the area of the shaded segment. Okay, that blue color shaded segments. Okay, let's find the area of the shaded segment first. Okay, how to find the area of the that shaded segment, which is nothing but the area of the sector ACO minus the area of the triangle ACO. 2 times area of the segment. Okay, area of the segment is equal to, so the area of the segment is equal to area of the sector ACO minus area of the triangle ACO. What is the area of the sector ACO? So the area of the sector is half r square theta. Here we know the radius is r, and what is the angle here? Angle at this part is pi over 3. R square pi over 3 minus the area of the triangle ACO, which is half multiplied by r multiplied by r multiplied by sine pi over 3. This is equal to r square pi divided by 6 minus 1 over 2 r square sine pi over 3 is square root of 3 divided by 2. So this is equal to pi r square by 6 minus square root of 3 divided by 4 r square. This is the area of the segment. So let's find the shaded area of the motif. This is equal to area of the major sector AOB, which is 1 over 2 r square, and the angle is 2 pi minus 2 over 3 pi. Okay. From that we need to subtract the segment, this shaded segment. Okay. So we need to subtract two shaded segments. So 2 times pi r square by 6 minus square root of 3 divided by 4 r square. Okay, let's simplify this one. This is equal to pi r square minus 1 over 3 pi r square minus 1 over 3 pi r square plus square root of 3 over 2 r square, and this is equal to pi r square minus 2 over 3 pi r square plus square root of 3 over 2 r square, 1 over 3 pi r square plus square root of 3 over 2 r square. This is the area, shaded area of the motif. The next question is, the diagram shows the shape of a coin. The three arcs AB, BC and CA are parts of a circle with centers C, A and B respectively. ABC is an equilateral triangle with the sides of length 2 cm. Find the perimeter of the coin. So now the size CB is given as 2. Okay. And it's given ABC is an equilateral triangle. So if you join A and C, B and A, okay, this will be 2 cm and this is also 2 cm, and this angle is pi over 3. So what is the perimeter of the coin? So first we need to find the arc length AB, then BC, arc length BC, and then arc length AC. Okay, adding all these three arc value will give the perimeter of the coin. So the perimeter of the coin is equal to arc length AB plus arc length BC plus arc length CA. Okay. So what is the arc length AB? The formula is r theta. So here r value is 2 and the angle theta is pi over 3. For all the three sides it is same. Three times 2 pi over 3, which is equal to 2 pi. Okay. So the perimeter of the coin is 2 pi. The B part of the question is find the area of the face A, B, C of the coin, giving the answer in terms of pi and square root of 3. So we need to find the area of the coin. We can find the area of the coin by finding the area of the triangle ABC and these three segments. Okay. All the three segments are equal. Three times area of the segment. So how to find the area of these segments? Let's consider this part. Okay. This is nothing but the area of the sector ACB minus the area of the triangle ACB. We have three segments here, 3 times that value. So first, what is the area of the triangle? Area of the triangle is 1 over 2 multiplied by r value is 2 square multiplied by sine, the angle is pi over 3. Okay. Plus 3 times the area of the segment is nothing but area of the sector minus the area of the triangle. Area of the sector is 1 over 2 multiplied by 2 square multiplied by pi over 3. That is the area of the sector minus area of the triangle, which is 1 over 2 multiplied by 2 square multiplied by sine pi over 3. This is equal to 2 times sine pi over 3 is square root of 3 over 2 plus 2 pi minus 3 multiplied by 2 is 6 multiplied by square root of 3 over 2, which is equal to 2 pi minus 4 square root of 3 divided by 2, which is 2 square root of 3. The next question is the diagram shows points A, B, C lying on a circle with center O and radius R. Angle AOB is 2.8 radians. The shaded region is bounded by two arcs. The upper arc is part of the circle with center O and radius R, and the lower arc is part of a circle with center C and radius capital R. State the size of angle ACO in radians. So if this angle is 2.8, okay, then this angle will be pi minus 2 pi minus 2.8. Okay. And angle AOC will be, this is divided by 2. Angle BOC also same, that is 2 pi minus 2.8 divided by 2. So angle AOB is equal to 2 pi minus 2.8. Angle AOC is equal to 2 pi minus 2.8 divided by 2. And let me take this angle as x, then this is also x, because the triangle AOC is an isosceles triangle with these OA and OC are equal, so it's an isosceles triangle. So these two opposite angles will be equal. Okay, so 2x plus 2 pi minus 2.8 divided by 2 will be equal to pi, angle in a triangle. Okay, so what is 2x? This will be, okay, let me simplify this here itself. Pi minus 1.4 pi minus 1.4. Okay, this pi and pi gets cancelled, so 2x will be equal to 1.4, so x will be equal to 0.7. Okay, so angle ACO equal to 0.7. The next part of the question is find r in terms of small r. So we need to find capital R in terms of small r. Let's consider the triangle AOC. We know three sides, two small r, one capital R. Okay, and we know one angle also. Okay, angle ACO is 0.7 and angle OAC is also 0.7. So let's use cosine formula. Cos 0.7 equal to r square plus small r square minus capital R square divided by 2 times capital R multiplied by small r. Okay, so this is nothing but r square divided by 2 capital R small r, which is equal to capital R divided by 2 small r, is cos 0.7. So r is equal to 2r multiplied by cos 0.7, which is equal to 2r multiplied by 0.7648, which is equal to 1.53 r connected to 3SF. The next question is find the area of the shaded region in terms of R. So how to find the area of this shaded region? First, let's find the area of this sector AOB. From that, we need to subtract this portion. Okay? And how to calculate this area of this region. To calculate the area of that region, first let's calculate the area of this sector. From that, if we subtract the area of this triangle and this triangle, then we will get this portion. So the area of the shaded region is area of the sector AOB area of the sector minus area of the sector ACB minus twice the area of the triangle. So let's find the area of the sector. Area of the sector is of r square multiplied by the angle is 2.8 minus area of the sector ACB. Here the radius is capital R. So 1 over 2 capital R square multiplied by the angle is, here it is 0.7. So this side 0.7. Totally it is 1.4. Minus twice the area of the triangle. The area of the triangle is 1 over 2 let's consider the triangle ACO and this angle which is 0.7. Okay, so the sides are capital R and small r. So 1 over 2 multiplied by capital R multiplied by small r sine 0.7. So this is 1.4 r square minus 0.7 multiplied by, for r square let's substitute, r is equal to 1.53. So which is 1.53 square and r square minus this 2 and 2 gets cancelled. For capital R let's substitute 1.53. R multiplied by r is r square multiplied by sine 0.7 which is 0.6442, and this is minus multiplied by minus plus. On simplifying this we get the final value as 0.747 r square. This is the area of the shaded region. So the next question, circle with center C of minus 4, 5 and radius square root of 20. So this is square root of 20 and this is square root of 20. So the circle intersects the y-axis at the point A and B. The size of the angle is theta. Find the equation of the tangent to the circle at the point minus 6, 9. Let me mark the point minus 6, 9 here. And this is the tangent at the point minus 6, 9. So we have to find the equation of this tangent. So we have got the center of the circle and a point which lie on the circle. From that we can work out the gradient of the radius. Basically the slope of the line going from the center to the point. So gradient of radius is 9. So consider this point and this 9 minus 5 divided by minus 6 minus of minus 4, we get plus 4, which is equal to 4 divided by minus 2. So minus 2 is the gradient of the radius. A tangent to the circle is perpendicular to the radius drawn to the point of tangency. So this is perpendicular. So the product of their gradient is -1. So the gradient of the tangent is 1 over 2 equal to negative reciprocal of the gradient of the radius. So we get 1 over 2. Okay. Let's write the equation of the tangent to the circle at the point -6, 9. Y minus y1 is 9 equal to gradient 1 over 2 multiplied by x minus of minus 6. So you get plus 6. So y is equal to 1 over 2x plus 3 plus 9. So 12. The next part of the question is find the equation of the circle in the form x squared plus y square plus ax plus by plus c is equal to 0. So here we have got the center of the circle and the radius of the circle. So the equation of the circle is x minus, what is the center? So minus of minus 4 will become plus 4 whole square plus y minus 5 the whole square equal to square root of 20 the whole square. So let's expand this. X square plus 2 multiplied by 4 is 8x plus 4 square which is 16 plus y square minus 10y plus 25 equal to 20. So x square plus y square plus 8x minus 10y plus 41 minus 20 equal to 0. So the equation of circle is x square plus y square plus 8x minus 10y plus 21 equal to 0. The next question is find the value of theta correct to 4 significant figures. So if you consider the triangle ABC, we know two sides and we need to find the angle. Okay. Let's find out the length of AB. Then using the 3 points by applying the cosine rule, we can find the angle theta. Okay, so what is the value of A and B? The circle intersects the y-axis at the point A and B. That means at this point the value of x is 0. So for this x is 0 and for this x is 0. Let's substitute x equal to 0 in the circle equation to find the value of y. So substitute x equal to 0 in the equation of the circle. So we get y square minus 10y plus 21 equal to 0. Let's factorize this one. Y minus 3 multiplied by y minus 7 equal to 0. So y is equal to 3 comma 7. Okay. Let's find the length AB, and before that let's find the coordinates of A and B. So y is 3 comma 7. So this is 3 and this is 7. Okay, let's find out the length of AB by using the coordinates of A and B. A is 0 comma 7 and B is 0 comma 3. 0 minus 0 the whole square plus 7 minus 3 the whole square, which is square root of 4 square, which is 16. Okay. So what is the cos theta? Cos theta is equal to square root of 20 square plus square root of 20 square minus square root of 16 square divided by 2 times square root of 20 multiplied by square root of 20, which is equal to 20 plus 20 minus 16 is 24. Divided by, this is 40. Divide the numerator and denominator by 8. So we get 3 over 5. So theta is equal to cos inverse of 3 over 5, which is equal to, so we need to correct to 4 SF. So 0.92729. So when it is corrected to 4 SF, we get 73. So this is the theta value. Next, find the perimeter and area of the segment shaded in the diagram. So the perimeter is arc length plus the length AB. What is the arc length? R theta, R is square root of 20 and theta is 0.92729 plus square root of 16, which is equal to 8.147. So the perimeter is 8.147. So what is the area of the shaded segment? To find the area of the shaded segment, first find the area of this sector. From this, subtract the area of this triangle. Okay. So sector area minus the triangle area. So what is the area of the sector ACB? 1 over 2 r square. So square root of 20 square multiplied by the angle 0.92729 minus area of the triangle is of the two sides of the triangle are square root of 20 multiplied by square root of 20. So square root of 20 square multiplied by sine of 0.92729. On simplifying this expression, we get the value as 1.27. So area of the segment shaded is 1.27 units square.